In statistics, data is classified in 4 main classes. That is raw data, ungrouped data on a frequency distribution. There is also grouped data on a frequency distribution. A frequency distribution is a table showing data values and its corresponding frequencies. In statistics, there are also terms that are associated with data. These terms can be classified in groups. Another type of group of this term is averages, or in short they call it central tendency. These averages involves terms such as the mode. The mode is the data variable that occur most often. For example, if we have data values 5, 4, 11, 8, 4, 4, 3, 10, 11, these are numbers separated by comma. That's if we make a tally table of this data. Let's see, here we have the variable and here we have the frequency. The variables are 5, 4, 11, 8, 3, 10. If you look here, we have 5 is 1 time. Now we have 4, 4, 4. That's 1, 2, 3. So 4 is 3 times. Now we have 3 is 1 time. We got 10 is 1 time. We got 11 is 2 times. Now the number which occurs most often is the number with the highest frequency, which is 4, since 3 is the biggest number here. You know that when data is written like this, that's not in a table, we call it raw data. So in this case, the mode is 4. Ungrouped data on a frequency distribution means data which is not in classes with their corresponding frequency on a table. Like for example, let's say the number of goals scored in a football competition and their corresponding frequency. Let's say 0 goal, 1 goal, 2 goals, and 0 goals occur 6 times, and here we have 9 and 3. You see, when data is presented this way, we say it is ungrouped data on a frequency distribution. And to get the mode of this data, we look for the data value or variable with the highest frequency, and here the data value with the highest frequency is 1. Thus the frequency of 1 goal scored is 9, and 9 is the highest frequency. So here the mode is equals to 1, since 1 has the highest frequency. Now for group data on a frequency distribution, the mode is always obtained by calculation. Here the mode is calculated using the formula mode is equals to L plus D1 all over D1 plus D2 all times C. L here is the lower class boundary of the modal class. D1 is the difference between the frequency of the modal class and the frequency of the adjacent lower class. D2 is the difference of the frequency of the modal class and the frequency of the adjacent higher class. C here is the width of the modal class. For example, consider the table below which shows the speed of a car in miles per hour and the number of cars. That is from 21 to 25 we had 22 cars. From 26 to 30 there were 48 cars. From 31 to 35 there were 25 cars. From 46 to 60 there were 9 cars. You know, because the data is arranged in classes, like you can see here, 21 to 25 is a class. There were 22 vehicles in that range with that speed. 26 to 30 there were 48 vehicles. So when data is arranged in such a way, we call it group data. So remember we said L is the lower class boundary of the modal class. You know, the modal class here is the one with the highest frequency, and it is this class because the frequency is the highest, that is 48. Now to get the lower class boundary of the modal class, we'll subtract 0.5 from 26 and then we add 0.5 to 30, and the modal class boundary will be 25.5 to 30.5. That is, from the formula, the mod is equals to lower class boundary, which is 25.5, plus D1, which is the difference between the frequency of the mother class and the frequency of the adjacent lower class. Now, the adjacent lower class is the class to the left of the mother class. This is the mother class. The adjacent lower class is this one, and the frequency of the adjacent lower class is 22, and the frequency of the mother class is 48. So D1 is equals to the difference between 48 and the 22, and that difference is 26. So it means in the place of D1, I'll put 26 over D1 plus D2. D2, it is the difference between the frequency of the mother class and the frequency of the adjacent upper class. The adjacent upper class is the class to the right next to the mother class. It is this class, and the frequency is 25, and that of the mother class is 48. So D2 is equals to 48 minus 25, which is 23. So it means here I'll have 26, which is D1, plus 23, which is D2. C is called the width of the mother class. The width of the mother class is the upper class boundary minus the lower class boundary of the mother class. That is, C is equals to 30.5 minus 25.5. Since the upper class boundary 30.5 and the lower class boundary is 25.5, which is 5. So it means here I'll multiply by 5. So if I compute this, I'll have 28.2 will be the mod.